Dear students, today we are going to move into the one of the most critical parts of explainable AI, which is not just how the explanations are generated, but what challenges exist in the making AI systems explainable and why even today, despite so much advancement in AI, explainability is still a major issue. Now, before we go on into the theory, I want you imagine a very real life situation. Suppose you apply for a loan through an online banking system. Everything is automated. No human interaction and suddenly your applications get rejected. And all you see is a message saying loan rejected. Now, what is the first question that comes to your mind? You will not just accept it. You will immediately ask why. What was the reason? Was it your income, your credit history, or something else? Now imagine if the system can't explain the reason clearly, what will you happen? You will lose trust in that system. And this is exactly the problem we are addressing today. Modern AI models, especially deep learning models, are extremely powerful, but they behave like a black boxes, meaning they give the very accurate predictions, but they do not reveal their internal reasoning in a way the humans can understand. So there is always a trade-off between the performance and interpretability, meaning if you want a very high accuracy, you often to lose transparency. And if you want to full transparency, you may lose performance. Now, another important issue in that different users need a different types of explanations. For example, a developer may want technical details. A regulator may want compliance justification. And a normal user may just want a simple reason. So, one explanation can't satisfy everyone. Also, there is no standard way to measure how good explanations is, which make evaluation very difficult. And finally, there are the ethical issues, because if the decisions are not explainable, they can lead to bias and unfair outcomes. So understanding these challenges is very important, because it tells us why XAA is still an evolving field and why need we the better solutions. Now let us break down these challenges in a deeper way so that you can connect each one with the real world systems. First, the complexity of AI models. Modern deep learning systems have a million of parameters and they process the data in layers. So, tracing exactly how a decision was made becomes extremely difficult. Let me give you a real example. Think about a recommendation system like a Netflix or YouTube or Instagram anyone. When it suggests a video, it considers thousands of factors like watch your history, preferences, time of day, and even behavior similars users. So explaining that the decision in a simple way is not easy. Now the second challenge is the trade-off between accuracy and interpretability. Suppose you build a simple decision tree model, it is easy to understand, but may not give a high accuracy. Whereas deep neural networks give a high accuracy, but is difficult to explain. So choosing between these become a challenge. Now the third is the human understanding gap. because explanation should not be designed only for experts. They must be understandable by normal users also. For example, the doctor may understand technical explanations, but the patient will need a very simple explanations. Next is the evaluation difficulty, because there is a no universal metric to say whether an explanation is good or bad. Unlike accuracy, which is very easy to measure. And finally, the context dependence, meaning what is considered a good explanation in finance, may not be acceptable in healthcare because the stakes are different. So these challenges show that explainability is not a technical problem. Okay, explainability is not a just technical problem. It is also a human-centered problem. Okay. So an AI system, say for example, an AI system rejected loan. Why didn't happen? No clear reasoning. That is. So explainability is not a technical problem. It is also a human-centered problem. Let me add one more perspective to those challenges so that you can relate them even more clearly. Think about how the humans explain the things to each other. When you ask your friend why they choose a particular answer in exam, they will give a simple explanation based on the logic. But AI system cannot naturally explain like a human because their reasoning is hidden inside the mathematical computation. Now another issue is oversimplification. Sometimes when we try to explain complex models, we simplify too much. And in that process, we may lose important details. So the explanation becomes misleading. So there is always a balance between simplicity and accuracy. Also consider the dynamic nature of the data. In real world system, the data keeps changing. So the explanation must also adapt over time. Otherwise, they become very outdated. For example, in a stock market prediction, the pattern change frequently. So the explanation that were valid last month may not be valid today. So maintaining up-to-date explanations is also a challenge. So when you combine complexity, the human understanding and the dynamic data, you can clearly see why the explainability is still difficult the problem. Okay, so challenges in XAA are not just a technical, they are the ethical, legal and social aspect. So another important point, scalability, because a model become more larger and more complex. Explaining them become very even harder. So researchers are constantly trying to find the way simplify the explanation without losing accuracy. So when you study these challenges, don't just think them exam point. Think as the real barriers that must be solved for AI to be truly for the society. Now think about the company side. Okay, I'll give you another example. Imagine you are using an AI-based hiring platform where resumes are automatically screened. And suppose your resumes get rejected. Now, if the system does not explain why you will feel frustrated and unfairly treated because maybe you have the skill, but the system misunderstood the something. Now think about the company side also. If they can't explain why the candidate was rejected, they may face legal issues or accusations of bias. Okay. So this is the mainly key challenges in XAA. Next, the important topics, additional properties. Okay, what does mean additional properties? Have you heard that word previously? Additional properties. Now let us move to the one of the most important parts, which is understanding what makes good explanation. Because not every explanation is useful, and we must define certain properties to evaluate them. Imagine a doctor using an AA system to diagnose disease. If the system gives us explanation, it must first be accurate, meaning it should truly reflect how the model made the decision. This is called fidelity. Okay, see this title. Now suppose the explanation is technically correct but too complex. Then it is useless for doctor. So it must be also be interpretable, meaning easy to understand. Now think about the consistency, third one. If two patients have a similar conditions, the explanation should also be in similar. Otherwise, the system becomes unreliable. Next is completeness. The meaning, the explanation should cover all the important factors. It not just a few selected. And finally, actionability, meaning the explanation should help in the decision making. For example, if a system says a patient is a high risk due to the high glucose level, the doctor can take the action based on that. Let me give you some simple relatable example. Suppose a teacher gives you marks and also explain why you got those marks. If the explanation is clear, consistent and useful, you will accept and improve it, right? But if it is vague or incomplete or improper explanation, you will feel confused or unfairly treated. So these properties are essential, right? Ensure that the explanations are meaningful and trustworthy. Now let us extend these properties further, because real world or real time systems require more than just basic explanations qualities. One important property is fairness, meaning the explanation should not reflect bias. For example, loan rejection system should not discriminate based on the gender or background. Next is robustness. It means small changes in input should not drastically change the explanation. Otherwise, the system becomes unstable. The third one is transparency. So transparency is another key property. So where the logic of the model should be visible and verifiable. Now, one of the most important concept is causality, because the explanation should not just say what happened, but why it happened. And this is critical domains in like a healthcare, financially. Okay. Finally, the explanation must be user-centric, which means they should adapt to the user knowledge level. I'll give you another more example. It will be easy to clear you. Okay. Already we saw this example. I would like to explain this additional desirable properties related to this example. For example, a doctor. Okay, in a hospital, a doctor. A doctor need the detailed explanation, but the patient need the simplest version. Okay, because doctor know the technical level, technical languages, but the patient doesn't know the technical language. They need the simple explanation. What is happening? What happening? Why happening? Okay, let me give you a real scenario. Suppose an AI system predict a disease for a doctor. It may be based on the biomarkers, but for a patient, it should say due to high sugar and weight levels. So the explanation must change based on the one who is receiving it. So the explanation is not just about the data. Okay, explanation not just about the data. It's about the communication. It's about the communication. So these are the additional desirable properties. What is the first one? Fairness, robustness, transparency, casuality, user-centric. Clear? Now let us move to the categories of explanations, which help us understand different ways in which explanation can be provided. First one is global explanations. Second one is local explanation. The third one is post-hoc explanation. The fourth one is anti-hoc explanation. We'll see one by one. The first is global explanation. So, which explain the overall behavior of the model, which mean what features is generally influence the decision. What features is generally influence the decision. Simply say that it describes the entire model's behavior. Okay, for example, a loan system. It may say income and credit score are the most important factors. Okay, so these are the main features the model uses overall. Okay, the second explanation is local explanations, which focuses on a single prediction, okay, or single instance. For example, why the specific loan was rejected. Okay, why the specific loan was rejected. Now the another one, third classifications is post-hoc explanations. So which is generated. What is mean by post-hoc? Generally meaning after that. Here also the same meaning as the word say that. Which is generated after the model make a decision, like a sharp or line. These are the widely used because they work with the complex model. Okay. On the other hand, the final one, anti-hoc. Okay. So explain come from the models are inherently interpretable, like a decision trees or linear regression. Let me give you a simple real life example. Suppose a teacher explained the general grading criteria. Okay. That is a global explanation. But if the teacher explained why you got a specific mark, that is a local explanation. Clear? So understanding these categories help us to choose the right explanation method based on the situations. Okay, hope you understood. There are the main four categories. What is the first one? Global explanation. Second one, local explanation. Third one, post-hoc explanation. Fourth one, anti-hoc explanation. Now let us extend these categories further. Some explanation are model specific, which mean they only work for certain models, like a CNN or visualization for image models. On other hand, the model are agnostic, meaning they can work with any model like a lime or sharp. Now the another type is feature based explanation. So where the system rank features based on importance. For example, age, income or glucose level. Then we have example-based explanations, where the system compare the current case with the similar past case. Let me give you a relatable example. When your doctor says this case is similar to previous patient. That is the example-based explanation. Finally, visualization-based. This explanation uses a heat map or graphs to show the important area. Because as the word say that visualization, especially or an image. So different explanations types serve different purposes, and selecting the right one depends on the application. I would like to more few 2 minutes to talk about this. Okay, let me talk you. Now let us come to some key metrics used in the evaluation. Fidelity, okay, fidelity check whether the explanation truly represents this model. Consistency check whether the explanations remain the stable for simpler inputs. Human trust the measures whether the users believe these explanations. Time efficiency check how the quickly can understand it. And the comprehensibility measure shows how the easy to for non-expert to understand. Let me give you example. If an explanation takes too long to understand, the users will ignore it. So the time efficiency is important. If it is too complex, the user will not trust it. So comprehensibility matters. So explanation is not just about correctness. It is about usability. Okay. So these are the taxonomy of explanation evaluation. Now let us extend the evaluation with the deeper understanding. Functionally grounded evaluation focuses on mathematical correctness, but it does not consider the human understanding. Human grounded evaluation, it focuses on usability, but it may not be guarantee correctness. The applications grounded evaluations is the most realistic because it tests the explanations in real world scenarios. For example, in a healthcare, if a doctor can use the explanation to make a better decisions, then the explanation is effective, right? So the evaluation must consider both technical and human aspects. Another important point is that evaluation is not one-time process. It must be continuous because the models and data keep changing. So the evaluating explanation is an ongoing challenge. Now let us go deeper into the evaluation metric, fidelity. So the fidelity does explanation match actual output, mean ensure the explanation truly represent the model. But the high fidelity explanation may sometimes be complex. The second one, consistency. The consistency is it stable to across similar output, which means ensure the stability, but too much consistency may hide the human important variations. The human trust is subjective, but meaning the different users may perspective or may perceive the explanation differently. Time efficiency is important in real world. How long does it take to interpret? Okay, which means the system where quick decisions are required. Then comprehensibility ensure that the explanation to non-experts. So no single metric is sufficient. We must consider multiple metrics together. this make a evaluation but necessary. Okay, hope you understood. So let me give you simple analogy. Global explanation is like understanding a syllabus, while like a explanation is like a understanding why you got marks in a specific question. Both are important but serve a different purposes. On other hand, they may not achieve the same level of performance as complex models. Okay, hope you got it. Now let us connect everything with the real world healthcare exam. Suppose an AI system predict that patient has a high risk of diabetes. Now the model used in the deep neural network, okay, which is black box. So the doctors use the sharp to identify important features. And the explanation shows that high glucose level, BMI and age are the main factors. Now, how do we evaluate this explanation? We check whether the doctors agree with it, whether it is consistent across similar patients, and whether it helps making the decisions. So this example clearly shows how the challenges, properties or categories and evaluation all come together in a real world scenario. Okay, clear? I would like to deeper explanations. Now let us extend the healthcare example further. Suppose an AI system predict the diabetic risk and provide the explanation using sharp values. Now the doctors must verify whether the explanation align with the medical knowledge. If it does, the system can be trusted. If not, it indicates a problem. Now consider the another scenario where the two patients have the similar conditions but receive different explanations. This would raise the concern about consistency. So evaluation must ensure reliability. Also explanation must be presented in a way the doctors can quickly understand and act upon. So because the time is critical in healthcare. So this example is clearly show how the explainability directly impact the real world decisions. So let me think one thing, entire the decision with the final perspective. Let me conclude this. I want you to remember one thing. Building the AI model is not enough. Making them explainable is equally important. Because without the explanation, AI becomes a black box that can be trusted. So the future of AI depends not only on accuracy, but also transparency and trust. And as a future engineer, your goal should be to build your system that not only predict correctly, but also explain clearly. Because at the end of the day, the technology should not just give answers. It should give understanding. Okay. So finally, conclude of this one. Let me conclude the entire session discussion with the final perspective. Explainable AI is not just a technical requirement. It is a necessity for building the trust in AI system. As the AI continues to grow, the demand for explainability will increase, especially in the critical domain. So future system must be designed with the explainability as a core feature, not an afterthought. As a student and the future, you must focus on the building the system that are not only accurate but also transparent and understandable. Because at the end of the day, the technology should not just the provide answers. It should provide the clarity and the confidence and trust. Thank you. Hope you understood.